Circuit analysis or electrical circuit analysis or circuit theory subject. University, first unit. Dot syllabus. Third unit. University syllabus and dot syllabus. Nodal voltage method. In this video, we see previously I explained KCL law and Ohm's law and how to apply nodal analysis method. Previous classes. Kindly see this. In this video, we see different circuits, that is, different current sources. Consider the sources like a core battery or torchlight cell. The voltage is not constant and depends on the current drawn from it. Such sources are known as dependent or controlled sources. In this circuit, dependent sources is availability, that is 0.5 Vx, and 6 ampere sources, that is DC circuit. Put node points 1 and 2 and reference point. At node point 1, nodal voltage is V1. At node point 2, nodal voltage V2 and reference point. Vx is voltage across the two more resistance. Node 1 meeting element is 6 ampere and 4 mho and 2 mho. Node 2 meeting element is 5 mho and 2 mho and 0.5 X. Voltage across the 4 mho resistance is small v1. Voltage across the 5 mho resistance conductance is small v2. Kirchhoff's current law. The total sum of the current entering at any node is equal to the leaving at same node. Total current leaving at same node. V is IR, that is Ohm's law, that is change and the form of I is Vg. Question: determine the voltage across each conductance of the above circuits. 2 mho across the voltage is Vx, put, that is plus minus sign, and 4 mho across the voltage is small v1. Small v2 is 5 mho across the voltages. Form at node 1, apply KCL. Node 1 meeting element is 6 ampere. 6 ampere, 6 is equal to, consider 2 mho conductors, 2 into, that is difference of V1 and V2 nodal voltage. V1 minus V2 plus 4 mho is depends on V1 nodal voltage plus 4 V1. Form first equation, and node 2 meeting voltage is 0.5 Vx. So 0.5 Vx is node 2 depends on 5 mho and 2 ohm. So 5 mho is dependent on V2. 5 V2 plus 2 into 2 mho and 2 mho is dependent on V1 minus V2. That is opposite. So put minus sign. V2 minus V1. 2 mho is dependent on the V1 and V2 nodal voltages. V1 with the opposite, so put minus sign. Vx is V1 minus V2. From circuit, we have 2 mho across the voltage Vx is. We form Vx, Vn minus 2 matrix format. 6 minus 2 minus 2.5, 7.5, V1, V2, 6, 0. That is I is Vg formula. Take mathematical function, determine value, inverse matrix value, 4-factor matrix value, and multiplication of voltage matrix values. We find nodal voltages at node 1 point and 2 point as V1, V2 we find. From V1, V2 we find a Vx value. Vx value is V1 minus V2. Vx is minus 0.825. Voltage across each connection. That is Vx is voltage across the 2 more resistance. From voltage across the 4 more resistances V1, that is 1.125. Voltage across the 5 more conductance as, that is nodal voltage V2, that is 0.3 volt. That is answer. Splitting pages I given for clarity purpose. Kindly notice. Answer we obtain Vx. Vx is voltage across the 2 more conductors. That is very important points. From this we find out nodal voltage is V1 and V2 is find out by node voltage method. Kirchhoff's current law and Ohm's law is applied. That is Anna University syllabus and dot syllabus. Node voltage method is in different circuits, that is circuits with dependent current sources. Kindly noted. Man engineering, thank you.